So, okay, by my clock it's 10 o'clock, so I think we can get started again when the slide people put my stuff up. But thanks everybody for coming by. I almost feel like I should preface this with now for something a bit different. Maybe not totally different, but here we go. So at that, I'm going to be, some of these slides are going to have kind of funny looking URLs on them. So that site that's there, I'm going to be referring to, I'm going to be having some example code up, and some of it is not, so basically note that site. The first part is the OHBM 2019 Etzel QC. That's not for the whole session, it's specifically for some of what I'll be showing today. So, okay, so I'm going to talk about what I call Dataset QC, and I had put in the abstract for the talk when I was proposing this talk that it's to verify that a dataset's contents match its description. And then then we heard Pradeep's talk this morning, and I was like, what I'm calling quality control, I think is what he would call quality assurance. I'm not really up on terminology, so I'm going to be saying quality control all the way through. I think you'll be able to follow. So at the first part, this is, you might be saying, why do I even need to talk about dataset quality control? This is a solved problem. You know, just run bids or the bids validator or something else like that. If you have the files, everything's good. And bids is very good. Don't get me wrong, I'm a very big fan of bids. But it's not sufficient. You can have a valid data set according to bids or a program like it where everything's in the right format that's still, unfortunately, unusable. It could be contaminated by some very serious artifact that you didn't find till late. You could have given the participants the wrong instructions, so you can't actually test what you had wanted to test. There's all sorts of nightmare scenarios where you can have a valid but unusable data set. So I don't see dataset quality control as something that you just do at the end. Instead, I see this as a set of procedures, stuff that's woven in all the way through data collection, acquisition, processing, analysis, as I think will be made clear. So I'm going to kind of go in that order, but it's not really that discrete. So why do we need it? I kind of alluded to this already. So that your data is usable, both by you now, today, by you in the future, by other people in the future. And also to maximize the chances that your analyses are going to produce accurate results. Unfortunately, there's a lot of errors don't make blanks. They make beautiful blobs. And I'm seeing some nods by some people that have probably experienced how beautiful erroneous results can be. And then also, just as a practical matter, an awful lot of grants now are requiring submission of the data set to a repository afterwards, or you probably want to do that anyway, and you have to have some of these pieces in place to be able to do it. And so I'm going to be getting in, and it's okay to ask if you have a very brief question as we go on, but hopefully there'll be time later. Okay, so what can this look like in practice? So I'm going to start with kind of a trip down memory lane to what I did with a study in 2007, though I have a feeling this is still going to sound very familiar to anybody doing task fMRI or any sort of fMRI. So there were two of us involved in data collection, and we used scripts and things to make sure that we were really giving, keep everything coordinated, make sure we were giving the screening questions right and stuff. And then as I was collecting the data, I put the files for every person into the separate directories, looking by eye to make sure all the naming was consistent, everything like that. Then I did the pre-processing in SPM, kind of a combination of clicking through the menus and then making batch jobs. I was actually pretty impressed with myself when I was looking for some of these files. I have, screenshots of, okay, here's how you set the settings for this SPM menu. So it wasn't too bad either. I could tell what I had done. And then as I ran analyses, I copy-pasted images from SPM and R into Word to kind of write up documents about it and share it with my colleagues. And is this manual, manual meaning kind of a lot of clicking around, dragging files, checking things by eye? Is this whole procedure horrible? Well, not really. I was impressed with myself that I could find the files and results and some of the descriptions 12 years later. But there were only 16 participants in the data set, and there were 2 of us running the experiment, so we were able to kind of keep everything under control. Is this procedure perfect? And no, I'm going to be pointing out some flaws and improvements and better solutions as this goes. So let's actually try one of these polls. I had the warning thing there. So this is a real online thing. So hopefully it says when playing as a slideshow, it will display live content, but it's not. So they must not have these online. So what the question was, if you can see it, let's see, I might be able to see on this thing. Yes, some people voted. So it looks like most people are saying, oh, there are still a few of you that are working with data sets under 30 people. It looks like about half, between 11 to 30, 31 to 100 has the most. Fair number with with the 101 to 1,000. But regardless of, whoops, if I can do the mouse. Oh, magic. Okay, so yeah, there's the results. So that is, if I can click out of this now. Go, next slide. Aha. So yeah, that's probably self-evident also, by the way, I was describing my 16-subject data set. Those sorts of clicking through workflows just plain don't scale up. And, come on. Okay, now we have like 4 of them. Okay, so I'm going to be talking about this data set that I've been involved with for a few years now. And we're currently at 90 subjects, but each of the subjects has multiple scanning sessions and all of that. And so it's a lot of data compared to what we used to work with. And this really isn't a big data set. The UK Biobank, aiming for 500,000. I'm not going to be clicking through 100,000 files to look to see if they're named properly and have the right contents. It's just plain impossible. And even if I wanted to, I would almost certainly make mistakes. So, because we're all humans. So, for one thing we all probably know about is that humans are not very good at visual search. So here's a little quiz. I'm going to put up a little screenshot, but you don't have to click on anything for this quiz. It's a virtual quiz. I'm going to put up a screenshot of a directory, and I want you to tell me find the typo. Which one of those has the wrong subject ID? And there's actually some clues, but it's that one. It has has a 77 instead of a 99 in it. And even though it was like highlighted, has the V2 next to it to give a few cues, it's really hard to see this type of error. And it's probably obvious, but these small sorts of errors can cause huge problems when you're doing analyses. If we happen to have a subject ID that had the 99 and the 77 instead of the 99, I could be pulling the wrong file, which of course could be really bad. We could if I was submitting the data set to a repository, that file would show up missing because it was misnamed, et cetera, et cetera. So a lot of you are probably thinking, well, duh, just run a script and check all the files. And yeah, we do that. So here's an example of, so what this is you just write a script. The BIDS validation thing does some of that. You can write your own to do it more consistently. That just searches the directory structure. So here we have in this first column, zeros mean missing, and there's a couple of people there that have missing files. So I start, being the project manager type person, I start investigating, and this one, the RA, they didn't, but say the RA forgot to bring the script. And that's why we don't have the status. So now we have to make decisions. Okay, are we going to have to invite this participant back in order to collect this missing data? What are we going to do about it? And then, okay, now I look in this person's directory and I see a file with an underscore. And it's like, oh man, is that a typo or is that some other file that got misnamed? So all of this, et cetera, et cetera, et cetera, when you're finding these kind of errors afterwards, it's a lot more work than if you can find them in the first place or not have them in the first place. And the number of inconsistencies like this that you're going to get are going to scale up probably exponentially with the complexity of the project and the number of people that are involved in data collection. Everybody's going to have their own idea of the best way to organize the papers and that kind of stuff. So this is kind of what I was saying. We're all human. Mistakes, surprises are going to be happening. We have to try to minimize the likelihood of errors. We're not going to ever get to zero. So how do I suggest doing this? Checklists and SOPs. So checklists, I do literally mean to follow and physically mark a paper checklist for every single participant as you're running them and possibly also as you're going through the data acquisition. And sometimes I get a fair bit of pushback from this idea. So I like to, this is one of my patented stories, that think about parachuters. So my husband was a jump master, and he went through hundreds and hundreds, thousands of hours of training, practice jumps, how to tell if every single part of the parachute was in working order. And that's, well, smart. You don't want just anybody telling you, okay, jump out of the plane now. But even after going through all of those qualifiers, he didn't rely on his memory or invent his own system of double-checking the parachutes. He had a checklist. The pilot of the plane had checklists that they went down every single time. And we might be saying, why? You know, I was just saying how much work my husband went through to get qualified. These people are smart. Can't we just trust them to do it the right way? Well, no, because expert humans, we are all still human. And strictly following well-designed checklists seems to be one of the best ways in practice to try to make sure everything's done every time. So I think that this is more acceptable for parachutes and pilots because it's really obvious what happens if there's an error. But an unusable data set is a big deal for us too. I mean, it may not be a splat, but it's still years and years and millions of dollars of wasted. So here just quickly, this is a screenshot of that I pulled from one of our checklists. We have them printed out. The RAs fill them out on paper as they go through the protocol. Then we scan them in afterwards, and they're stored with the rest of the files for that person. And so that also gives a bit of accountability in that we do all look at these. They know they're stored afterwards. And then these are kind of living documents that you're always updating if things go wrong. And yeah, that's what I was just saying too. And I'm not saying these are like perfect. It's just every experiment, every center is going to need a different set. So beyond checklists, SOPs, standard operating procedures, are explaining how to do the steps that the checklists are just to remind you of. Here's a bit of ours just to kind of give an idea. This is a massive document, but it's also a pretty big project. The detail, again, I think generally needs to get more, you know, the complexity is going to be increasing as the number of people, duration of the project, all that increases. But really, I think if an experiment is important enough to be run, to go through ethical approval, get the funding, all of that, it's important enough to have an SOP formally written out and actually released with the data set. I think it ought to be considered an essential part of the data set. So this is kind of, so that was kind of some high level, maybe like managing the people a bit, trying to minimize errors. This is a little bit of a shift, though it's still in that flavor of talking about scripting, because how you set up your procedures can make a big difference in how quickly you're catching errors. So for a concrete example, we use ePrime to show our experiment stimuli. It's like CyclePy presentation. There's a lot of those sorts of programs. And it makes its own outputs, which we convert as quickly as possible out of the proprietary format into just text. So one way to do this is that the student or whoever could click through box where our files are, highlight the ones for the person in the raw directory, download them all locally, open up ePrime, put the files into it, click through the menu conversion, save as with the new name, and then upload the new files to the new directory. And yeah, that works, but who the heck wants to do that? And it's really, really prone to errors. You know, if you make a typo all the way through, it's problematic. So a better way to do it is that bit of our code, and this is one of those files that's actually in that directory I was talking about. It won't work for anybody else's code, but some of the checks and how we're pulling the files from Box, everything else would work for other files. So the steps with this is just you pull a copy of the script if you don't already have one. At the top little bit of the file, the person running it enters in the subject ID and this which DMCC, which is referring to sessions and waves. And then you run it. And if there's no errors, you're like, okay, we're good. And I'm confident of success with this because I know that the script was designed to fail. If something is not exactly correct in the file naming, the location, all of that, it fails. Do we catch everything? No. These are also updated when stuff slips through. But it does seem a lot safer. So again, I consider these standard template scripts kind of part of the data set procedures. Okay, so another one is that even the best automatically generated quality control summaries aren't going to be practical if they're just too big. So this is a little bit of some of the fMRI prep output that it makes. So the fMRI prep, if you ever done pre-processing that way, makes beautiful output. But one of our participants has well over 50 pages of stuff to scroll through. And that's a lot. It's really hard to look at that quickly. And then like these XNAP burn ones, they're also pretty cool, but there's one for every single run. And when I have 100 or more runs per person, that's, again, a lot of clicking. And that kind of, yeah, that sounds whiny. And maybe I'm just lazy with my mouse, but it's also human nature. I can't kind of mentally remember across 1,000 pages of output how the movement was looking in relation to my task. I just plain can't do it. So the alternative that we found work really well is to use these dynamic reports. And I'm going to do a little bit of illustration over the next few pages, hopefully to illustrate what I mean by that, because I'm not really sure of an exact name for this strategy. And it's basically summarizing what we find for our experiments to be the most key things, and then we can always go back and look at the full reports when we have to. So again, here's the source. So this is, for our particular study, I make a lot of plots like this to summarize the movement, and the details don't matter, but there's some horizontal lines there that are actually giving our task blocks. So for this thing, I can see that, okay, this frame hit our censoring threshold, and it's in between our two task blocks during a rest period. So the person probably just looked like they moved a little bit during the rest period. I'm not going to worry about this. So this is just a way to show for us some of the stuff that's been useful. Then we also include these TSNR, standard deviation type images, totals of censored frames. And what these look like is there are these big reports that have all these elements in them all together, so I can easily scroll through for one person altogether. And just one more quick summary example is this for behavior. And this URL, this is actually the only one that I managed to get live as a full tutorial, example code, example everything beforehand. Hopefully more of these will be added. But yeah, that URL has the code and explanations in a lot more detail. But basically, I really like this kind of plot. And what this is these sorts of things. This is one of our tasks, 2 runs, and all of these little tick marks are trial onsets. Then these pinker lines are which button they pushed and when, and the little tick marks are if the trial was correct or not. So with a little bit of practice, the RAs are actually quite good at looking at one of these and saying, Joe, I think you better look at this subject. So we've had like one person about halfway through a run just stopped responding. And that's different than if, somebody can have low accuracy, pretty consistently, or you can see they're hitting buttons, but they're always wrong. You know, those kind of behavioral things can be really hard to spot if all you're looking at is average RTs or average accuracies. So this kind of plot for our tasks has been working very well. And obviously this is our tasks, but something like this probably would work for other people's tasks. We also have code in the files to automatically count. You know, if it said it was an NN trial, was the word that was shown as at this time actually shown at that time to actually check the experimental manipulation? Because if something goes wrong, we want to know it right away. And then stuff about performance. So what I was saying is all of those I was showing you, these are just little snippets of these dynamic reports, these that are, in our case, PDFs compiled from knitr code templates. And I really, really like R and knitr. I'm going to be talking about it at the Open Science Room in like a 5-minute thing. So ask me for lots of details, but it doesn't have to be R and knitr. So I use R, LaTeX, and then PDFs, but you can actually use Python for the code, Markdown instead of LaTeX, HTML, and you know, there's a lot of options that will work with the same strategy. The key is that it's a little bit like Jupyter Notebooks, if you're more familiar with those, in that you're mixing the code and the text together, but then you compile it into a static document that can then be archived. So here's a little bit of one of ours. You can see the text bits were LaTeX in the template, and then all of these brain images were read in an R loop, sent to a plotting function, plotted out with the threshold. And there's some tutorials on making brains into these files on my blog, mbpa.blogspot.com. Look for the knitr tag. So there's a few big advantages of this kind of thing. So one is that in that 2007 study I was talking about, I was summarizing everything for my collaborators by copy-pasting result images into Word. I don't do that anymore. Everything now is completely in knitr, and we have most of the lab doing it. And a big advantage is that you can actually check the sources. So if you're looking at one of these, you know, if somebody sends me a file and, oh, this is the contrast I got, and I'm like, did they actually pull the contrast they think they pulled? You know, is that the right image? With a knitr, I look in the R and W file, the source file, I look for the path of which image they plotted and look to see if it was the one that they should have plotted. But with a Word, you've probably all done this, where you have to look, is there a note that says which contrast the file should be? Can I find the file? Can I open up AFNI, overlay it, you get the message. So, but a big caveat is that confirmation, this linking, only works if you absolutely keep the PDF and the source file together. If there was a way to actually connect them, I would. But as we do, this is some of our storage directories, we just always have pairs of these files. And if you look in that sample directory I gave the URL to, you will see pairs of compiled and source files are always kept together. So this, I said I work in knitr basically always if I'm working on a new analysis, anything like that. I don't copy-paste anymore. And that's good if you're doing stuff interactively, but sometimes you just want to have, a set of standard files. You don't want to be doing everything one at a time. So for those movement files I was showing you earlier and the behavioral summary files, those are something that we want run on every single subject. I'm not going to be interactively making it up again every time. It's a standard thing. So to make those standard, I make a knitr template, except I have these key variables, subject IDs and stuff blank. And then I have a script that I wrote, start here, and there's an example of this in the directory. So the RAs, or even the undergrads, can do this with a smidge of practice. They open up the start here script. They write in the subject ID and a couple other things of which session they want to run. They run the script, and it makes this entire directory structure and puts in that subject's information into all of the source knitters. So if I open this up, there would be a couple dozen knitr files in these directories. And then I also have this knitr commands So what they do then is just they source knitr commands. They just run it, and you can see that it's setting the working directory and then compiling every single PDF and moving it to a directory. And you can see the output of this in the directory, but then we get a full set of results for each person all at once. And that was what I was saying. We found this to work quite well. You know, somebody has to initially write and maintain the scripts and templates, but then pretty much anybody can run them and look at them and alter them. So this next piece, I'm almost to the end, is kind of what I consider almost the big payoff, in the sense of trying to make sure that my entire data set is set up properly and that I'm going to be able to trust the results of my GLMs. So I tend to call these control analyses. I don't know that there's a proper term, but it's basically a positive control is a strong effect that has to actually be there. So for example, and to then look if it's there. So one of my favorites for this is button pressing, because since we do task fMRI, people are usually pushing response buttons. So I know when every single participant actually pushed a button, and I know where the left motor, where in left motor the finger is. So if I can't do a contrast of button push, not button push, and see motor, something went wrong. And also, if you can't see that, if I can't find button pushing, should I believe some sort of Sternberg length effect related to motivation in the, if you can't find motor and you're looking for something subtle, I wouldn't believe anything subtle if you can't see the control, I guess is what I'm getting at. So I really do think of this as a necessary first step. You can usually find visual something to use as one of these. That's what I was just saying. So, this is just a picture of one of these from one of our standard files of a single subject. And the colors are kind of lousy, but you can see that, yeah, that does look like motor in this single subject GLM. So here's kind of the thing, is that using these controls can be, what I was saying, a really positive test. So this is another view of one of them. We're running FIR tent models. It doesn't really matter. But this is a parcel average for a single subject off of these button pushes. And the point is what I had highlighted here, that these are 3 separate tasks and actually on 3 separate sessions. So, and in each one, at this sort of time that I highlighted, it goes up. The coefficients increase in this sensible motor region. And that's what it should be. That's the button pushing. But for this part of this automatically generated knitr, which was made from one of these templates I talked about, to look like this, that means that my R code must have found the GLM output that AFNI, in our case we're using AFNI, so it was able to find the statistics objects from AFNI, find the correct fields in them, pull out those images. Well, and that must mean that the AFNI script's finished, because otherwise I wouldn't have the AFNI output. And that must mean that the event onsets were right, because if the events weren't there, then the AFNI wouldn't have run. And also, if it wasn't able to find the button pushes out of the E prime, then the button pushes would not have been aligned enough to make this little blurb in the motor area at the button times, and et cetera, et cetera, et cetera. I can do this whole logic of all of these steps had to have been completed in order for me to get this picture. And I could do similar arguments about some of the other parts. But this, to me, is actually the big payoff here, that to set up a procedure that allows you to make this kind of chain of logic. I'm not relying on, okay, hopefully, did the grad student, to be mean, click around a couple times until he managed to get found the one that looks like motor. I know that, and I'm seeing nods. Some of you guys know the kind of phenomenon. If you know what it's supposed to look like, you can kind of poke around a little bit to try to make sure you have it. But with this kind of setup, you can set it up to actually, it's not that it's all black box, but it's that you can set up some of this logic. So to kind of try to wrap it up, I was thinking that the goal of Dataset QC is to verify that the contents match its description, something that has to be true in the very broad sense and kind of the quality assurance sense of PRODEEPs for the data set to be usable. And I'm trying to give the argument that it's not something that we just do at the very end, but it has to be rather woven into all of the stages with these checklists, scripts, standard operating procedures, all of this to really try to increase the chances that we're going to get a workable, usable data set out at the end. And the consequences are not really as obvious and severe as for a failed parachute, but they are really serious. I've been in projects that have been derailed because the errors were found late. In one case it was fraud. Another case there was unacceptable movement, really bad artifacts. You know, this kind of stuff has happened. I would imagine a lot of you have been involved in projects that years of data collection were just tossed because it wasn't usable. And even if you can try to pull something out, it can be really hard. And there's no perfect solution, nothing that's going to guarantee a flawless data set, but we want to do this environment to try to minimize errors and catch them quickly. So that's it. Oh, and nobody flagged me down, so I actually went a bit long now that I'm looking at the time. So if somebody has a really urgent question, otherwise I guess we just have to wait till the end to try to keep on schedule. So, thanks.